Now I'm ready to complete the assembly. I've opened the data panel and I'll right-click on the guide plate, select Insert into Current Design. Hold down left on the Y-axis arrow and drag the guide plate some distance away, and then Enter to end this command. I'll start Join. Make sure that it is on simple mode. I want the guide plate to move, so that's going to be my first one. Let me turn this around so that I can select the diameter of one of the holes and turn this back around to select the corresponding hole for snap 2, right here, this diameter. It's set on a rigid join. That's what I want. I'll click on the arrow and drag, then type in -6. Notice that this shows up in the Z offset, but we are moving in the Y direction. I'll go ahead and click OK. I'm going to close the data panel so I have more room in the canvas. I'll select the piston in the browser and move it so it's out of the way while I join it to the plates. I'll right-click and select Repeat Join. I want the piston to move, so that will be my component 1. I see that the snap is not selected yet. I will do that now. And that way I can select the top of the chamfer. And then my second snap is the diameter of the hole. This is set to rigid, but I want the piston to move. So I will click on that arrow and select Slider. Now I need to set my limits. I'll click on the Motion tab, check the minimum box, and leave it at 0. I'll check the maximum box and make it 5. Now I can play the preview and make sure I have my limits set correctly. That looks good, so I'll click OK to end the command. In the browser, I'm going to click on the piston and then select the pencil to edit the piston. I'll expand the Modify panel and select Physical Material. I'll open the Metal folder and scroll down to find Aluminum 6061 right here. I'll click on it and hold down left, drag to the piston, and then let up. And now the piston is the aluminum. I'll enter to close that command and select Finish Edit in Place. The next thing we're going to do is create a threaded rod. I will start a new design. I'll click on the plus sign on the right side of the Applications bar and go ahead and save this as threaded rod. It's in the correct folder, so I'll click on Save. I'll start a new sketch. On the XZ plane, start circle. Make sure I'm getting the center point of the sketch, and the diameter of this circle is 0.375. I'll finish sketch and right-click, start press pull, select the circle, change the direction to symmetrical, select the total distance, and type in 7.8. I'll go ahead and click OK. Expand the Create panel, select Thread, And everything's set to auto. I do want to uncheck full length. Click on the end of the rod. Make the length 0.4. Enter to end the thread command. Right-click, repeat thread. I need to uncheck full length. Select the other end of the rod and set the length to 0.4. I'm going to insert nuts on each end of this rod. So I'll click on the fastener from the Insert panel. The fastener palette opens. Here, I'm going to select nuts and hex. I'll filter this by ASME. Scroll down. Actually, here's the nut that I want, the hex nut. The palette changed, and I can drag the nut and place it on the threads. This, once again, auto-sized, but I do need to pick a plane. Fusion expects us to place this nut on a bolt up against a surface. So I'll turn this around and select the end of the rod. I want to make this a coarse thread pitch. So now it does match the threads on the rod. I'll click on Create and Continue and place this one at the other end. Turn it around, select the end, and then enter to finish this command. I'll right-click on the joint symbol and select Edit Joint. Use my arrows to drag this in the -y direction. Once again, it's showing up in the Z offset, and I'll type in -0.4 and enter. Repeat the same process at the other end. And this is at -0.4. So I'll just let up and click OK to end this command. I'll save the threaded rod and close it. Now the only design I have is the cylinder assembly open. I'll open the data panel and right-click on threaded rod, select Insert into Current Design. In the palette, I'll select the point-to-point option for the move type. That's all the way over to the right. The point of origin, I'll zoom in here, is the surface of the nut, and then my target point, I'll turn this around, is the diameter of this hole on the exterior. And then end this command by entering. Double-click middle mouse, expand the Create panel, and select Pattern Rectangular Pattern. I'll change the object type from bodies to components, and then select the threaded rod. In the palette, I will click on Select Axis and choose the Z axis. The blue arrow is the vertical. That will be the first direction, and the quantity of items is 2. Oh, that moved the heads-up display up here. When I click on these 3 dots, I now have some options I can measure this. If I didn't know the distance between my holes, I could use this to find that out. But I do know the distance, and it is -4. Now I'll click on the horizontal arrow and go through the same process. The number of items is 2, and the distance is -4. I'll go ahead and click OK. Click on my home, just so this is oriented in a direction that I'm used to looking at it. I want to turn off all of my joint symbols. I'll go down to the display settings and select Object Visibility, uncheck Joints. Click out in white space. The final step to complete this cylinder assembly is to upload the barrel. You should have downloaded it from the eLearn content. I'll click on Upload, select Files. It's right here. I'll just double click. I see listed the file that I need, so I'll click on Upload. The barrel is available in the data panel. I'm going to let you insert it and join it on your own. When you get that completed, you will have one file to submit into the Dropbox for your assignment.